Hello world and welcome to this edition of Tech on Fire with Blaze and Blaze Stewart, architect at Monolith. And today we're going to be looking at Azure IoT Hub again. We're going to be looking at file uploads and we're going to be looking at direct methods by way of the SDK and through the lens of the Azure IoT Hub. Hi guys, today I want to take another look at Azure IoT Hub, and we're going to be looking at direct methods today as well as file uploads. And these are two features that are supported by IoT Hub for the purpose of doing things that are very common in IoT workloads. One is obviously sending a file, but the other one is direct messaging, which is a form of root procedure calls that you can use in your applications that are going to be running on your devices. What this basically allows you to do is send a message to the device. And it's basically encapsulated the same way that the rest of the messages that are sent to the device, but it has a special payload that can be used by the SDK to interpret that as some kind of remote procedure call. And so what we're going to be able to do then in that case is do something on the device by way of invoking that by the way of the cloud. That's different from a cloud to device message, although you could probably do the exact same thing with a cloud to device message. This is specifically for the purpose of doing remote procedure calls. And of course, file uploads is pretty straightforward. That's where you take some file on a device and upload it to the internet. Now, for the demo I'm doing today, basically I'm going to be using a motion capture device that's going to basically look for motion. And when a motion detection happens, it's going to record that by way of a video, and then it's going to upload the video to the internet, and then it's going to send a message saying, hey, there's been some event that has happened on the device, a motion capture event, and here's the video for that. And that's what we're going to be looking at. And to turn the camera on and off on the device, we're going to be using the Azure IoT SDK, and we're going to be invoking that by way of calling through the Azure IoT Hub down into the device to turn the camera on or to turn it off. So this will demonstrate the idea of what we're going to be doing with this, and we'll be able to see the results in the Azure portal as well as other types of utilities that can look into this as well. I'm here in the Azure portal looking at an IoT Hub instance. Now, this is an instance of IoT Hub that is I set up for the purposes of uploading files to it as well as sending messages to it. And we looked at messaging last week where we did cloud to device and device to cloud messages using a device simulator. Now, to do what I'm trying to do here, I wanted to actually get a real working device that does something that's more than just a device simulator. And that's what I'm going to be demoing here. So I'm going to be using primarily the portal to look at a lot of the stuff that we're going to be looking at, although you could use other tools to do the exact same thing that I'm going to be doing here. Now, the one feature that I do want to talk about is file uploads. Now, file uploads in the context of an Azure IoT Hub instance is basically going to take something and put it into a storage account. Now, depending on how much data that you plan on sending up through a file upload, depends on how much data that you're really going to need for the kind of capacity that you're going to be putting into your storage account and also the tier. So if you're not planning on uploading a lot of data, then you could probably use a standard tier. But if you plan on using IoT Hub to receive a lot of files from the various devices that are going to be connected to it, you might want to go with something like premium or something like that so that you have the throughput and you're not going to be throttled by a bunch of concurrency that's going to be happening against that particular storage account. Now for mine, I have this one right here. And if I wanted to clear this, I could and just set it up again. It's very easy to do. You just click on this and then you find your storage account and then you pick a container. And the container is basically just going to be where it sticks the files. And then what it's going to do inside the container is partition the data based on the device ID. And so whatever device ID I have is going to be essentially a folder in my storage account. And once I have that, I can save it. And that's all wired up. Now, the storage account is used by all the devices. So if you wanted to have a different storage account for different devices, you'd have to get a separate IoT Hub for those devices, or you'd have to implement something external to the SDKs that are a part of this. So you would have to basically upload it to a separate storage account by way of the SDKs for storage and not use the IoT Hub SDKs in that case. In any case, this is what I've got, and that's what I'm going to be using for this one. So that's very straightforward and easy to do. Now, the other thing that we're going to be looking at in this context is device messaging, that we're going to be sending down direct methods to a device, and that's going to be invoking something on the device, essentially a remote procedure call on the device. And the way that you can do that in the portal is look at the actual device itself. Now I have a device registered already, and I called it camera one, and I'm going to open this guy up. And if you look at this one here, I can do a direct method. Now the direct method is basically a name, and it can have a payload attached to it. And that payload gets sent down by way of essentially a request response type model, where the request is simply is like an HTTP request, and then the response is something that you can send back up to the cloud once that's been processed. It does have a timeout and that kind of thing, so it's got to kind of respond fairly quickly. So you probably want to invoke stuff asynchronously, or have a message to follow up something beyond that, whatever is going to be calling the direct method. But I'm going to be calling it from the cloud. So this is how you can do it in the cloud. Of course, you can do it by way of programmatically calling it, or you can use some of the tools that are available, such as Visual Studio Code or IoT Explorer, or any of the tools that are available for working with Azure IoT Hub. So this is the code that's running on my device. Now, my device, as I said, is pretty straightforward, and this is just the wrapper around a daemon that is called motion. Now, motion is a motion capture daemon in the Linux context or the Unix context. And what it does is it basically turns on a camera and takes frames from that camera and then compares older frames to newer frames and looks for changes. So if there are changes in the frames, then there's motion that has been detected. And then what motion will do then is start recording a video. And whenever the time expires, I think I have it set to something like 15 seconds or so, it will notify this application, hey, motion has been detected. And then this application then uses the Azure IoT SDK to upload the motion capture by way of a video up to the storage account, and it will then send a notification saying motion was captured. Here's the file, and that's what we're going to look at. But I'm going to look at the code written in Node.js. Now, of course, you could write the same code using .NET Core, or any of the other available SDKs that are for Azure IoT Hub. I'm just using this one because it's Node.js, and I love Node.js. In any case, here is the protocol I'm using. I'm using MQTT, and you can see here that all of these are supported. You can use AMQP in HTTP, or MQTT over WebSockets, or AMQP over WebSockets. Both of those are supported. The protocol kind of all works the same. Now, they each have different features associated with them, but the bottom line is pick a protocol that's going to work best for you. I like MQTT because it's lightweight and it really doesn't require a lot of overhead, and it's very reliable and very performant, and it's really used widely in the IoT space because of that. Even more modest devices can handle the protocol, while some of these other ones require more overhead and heavier libraries. MQT is really light. That's why I'm using it. Now, I'm using a RAM disk here, and that's why you see this. Now, Motion will write the file to the persistent storage device. It doesn't have a way to buffer it. So I just created a RAM disk to keep it from wearing out the storage on the device. I just use the RAM, and it writes to the RAM using a RAM disk, and then I can just read it off the RAM and use that like a buffer, and then just upload it to the internet, and then delete the file once it's been uploaded off the RAM disk. So that's just the whole reason I'm using that rather than the actual permanent storage on the device. Now, here is the actual bread and butter that we're going to be working with. Here is the client object and the message object, which basically starts the client connection back up to the cloud, and then the message is what encapsulates the device to cloud messages that are being sent up to the cloud. Now, I obfuscated my connection string, but this is brokered by the connection string, and then there's the protocol that you inject, and I'm using MQTT. Now, once you have the protocol and the client set up, the next thing to do is just set up some handlers. Now, these are all handlers that you can set up. These are just generic handlers for messaging, for cloud to device messaging. And this is just to handle that. I mean, I'm not really using it in this application. It will just print the body out. It doesn't really do anything other than that. And of course, an error function. The bread and butter of everything that we're going to be looking at today is mostly in this connect handler right here. And this is what is actually going to be doing the uploads and all the other stuff. And this actually gets fired whenever the establishment of a connection is brokered. And once it's stable, then this actual code will fire here and wire up everything that needs to be wired for the client. And these are my event handlers down here. And the event handlers are the ones that actually turn off and turn on the camera. And as I mentioned, I'm using Motion. So motion being a daemon, all this is really doing is just starting motion. So it's basically starting a process that's a daemon in the background or killing that process by way of pkill. And it's using a request response model that you see here. So the request comes in, turn it on, and the response is, oh, turned on, camera turned off, or camera turned on, whichever it might be. And that's pretty straightforward for turning off and turning on the camera. Now, these are the actual handlers for that, but the actual code that invokes that we'll look at in just a second. Now, the rest of this code is just some, stuff to wire up the various functions for the events for the client. So on connect, on error, on message, and so on. Now, the code right here is the one that wires up the direct methods, which is turn on the camera and turn off the camera. You can see that's pointing to those two methods that start motion or stop motion. And this one right here is turn on camera, and that's the name of the direct method that I can invoke from the cloud. And it will turn on the camera if it sees this method from the cloud. And the same thing for this one. So if I just put that in without parameters, it will work, or with parameters for that matter. I'm not really using it, but you can send a payload as part of this. So that's how I can turn it on, turn it off, but that's pretty straightforward. Now, the server right here, this object right here that you're seeing here is a way to allow motion to tell me that something happened and a motion capture happened. Now, I'm using basically a pipe to do that, or a socket. Now, you could use, I tried to get this working by way of FIFOs, and I just could have very limited success with that. I just couldn't get it to work. So instead, I just resorted to just using a socket, and that's pretty, works pretty well. It's just a local host socket running on port, I think 80,000 or something like that. Yeah, right there. Port 8000, and then it just basically uses a command line to send a socket connection into this, and basically the data is the file name. So if I see a new file that motion sends over to this by way of a socket, then it says, oh, here's a new file that's been created. I can then read that file and then go to the internet and post it, and then I can notify the cloud when something has been posted to the storage account, there's a new capture available, and so on. And that's what this code does basically, is on data. That's, the data, the file itself is the file path for the local new motion path. It uploads it using the file upload part of the SDK, and then it deletes it after it uploads. And it also sends a message right here saying something has been uploaded to the cloud, and we'll be able to see that when we monitor this code, which I'm going to be using Visual Studio Code to do that. So I've SSH'd into the device that I'm going to be using, and this is the client output. So this is going to be the console output for the device. And the code that we just looked at is now running on the device. And I'm going to be interacting using Visual Studio Code for this. You can also use the portal, or you can use Azure IoT Explorer too. Now, the reason I'm going to use this is because I can start looking at the endpoints. So if I click on any device and I go start monitoring built-in endpoints for that device, it's basically going to connect to the backend service bus that is connected to Azure IoT Hub that handles the message brokering for an Azure IoT Hub. Now, you can get that information in the portal. If you go here to the Azure portal, you can see the built-in endpoints right here under Hub's settings, and you can get the connection string for that right here. And there's mine right there. And you can copy and paste that into Visual Studio Code to connect it up. But once you have that, you can right click on this, start monitoring built-in endpoint, and it's going to start the monitoring of that. So camera one is the device. The camera one is also the client that is connected from the device that I'm interacting with. So now that that's connected, what I can do then is I can now send a cloud direct method to that device to turn on the camera. So the device is running. However, I have not yet activated the camera. So I can use the portal to do this, or I can use Visual Studio Code here. I'm going to use Visual Studio Code to invoke the direct method right here. And that is turn on the camera. So if I go back to the code that we're looking at, I should have it in code right here to make it a little bit easier to work with. But I just prefer to write JavaScript inside of Notepad++ in any case, but that's more preference. But here you can use Visual Studio Code if you so choose. And I'm going to put in the name of the direct method, and it's called turn on camera. And I don't have a payload, so I'm just going to enter. And if all goes well, I should start to see some telemetry start coming through, as well as I'm going to put the console to see what it looks like. And there's also a LED on the device, and the LED came on, and that's telling me basically that capture started. And if I come back over here to the device, you can see that the client is connected. Now, if I wave my hands in front of the camera, it should start picking up some kind of telemetry there. And this is not my camera that I'm using to record this. This is a separate camera on the device. And I'm waving my hand on it in front of the device, and the LED is still on, and we'll see if it actually captures some data. And we'll wait for that to come back. So now we can see that the motion capture, it detected that, and that was motion telling me that I have a new motion capture here. And so basically it's a file, and now the SDK is taking that video file and uploading it to blob storage. And now the upload was successful, the message was unqueued, and I should be able to see that message down here in Visual Studio Code. It's just pointing to the file. So that's telling me that I have a new motion capture sitting out there in blob storage after motion captured it, and then I used the SDK to upload to the blob storage by way of the IoT Hub, and then it sent me a message. It's basically just telling what the file name is. And so I already know what the hub name is and the device name is, camera one, and this is the file that I should be able to go over to Azure and look at. So let's do that. Let's go pop that up inside of the browser, and let's go look at my storage account right here. So I'm going to browse out to my storage account, and let's go over here to my containers, and let's look at motion capture right here. And that's the name of this. There's camera one. There's the actual file. It's about 16 megabyte file, and that is just video file. If I download this, it should see me waving my arms in front of the camera once I launch this inside of this particular one here. So there's me talking, and it started me, and there's me waving my hands in front of the camera and trying to start the motion capture on the device. So all in all, a fairly straightforward demonstration of me capturing the device, uploading the file, and then invoking a message to send the telemetry over to the cloud. Now I'll probably still doing it in the background. So the next step is to turn the camera off. Now to do that, I'm just going to invoke a new method by way of Visual Studio Code. So back over here, I can invoke another direct method by way of the output right here, or I can do it from the Azure portal. And I'm just going to call the counterpart to the turn on, which is turn off. So if I turn off the camera, I should see LED turn off. I don't have a payload, and I should get camera turned off right here. And it finished uploading. It cut off a video and it finished uploading it, and therefore it notified me because I turned the camera off. It stopped recording, and then it's uploading the whatever it captured in the interim there between me starting the second capture and the actual message that just came in for that. So we got two files out there now. So here is basically a demo that's looking at the ability to use direct methods and file uploads. I'm going to build on this some in the upcoming weeks, where I'm going to be looking at various features on the Azure IoT Hub, such as twinning. And we're going to be looking at how you can use that for device configurations. And we'll also look at modules and other kinds of various features like that, where we can kind of build out more of this using the SDKs. And we're going to look at Azure IoT Edge as well. But this is just looking at this two features today, which are very common in IoT applications. If you like this content, please consider checking us out online at www.winelec.com, where you can find several blog entries about topics related to Microsoft Azure and software development. And you can also subscribe to this channel by clicking the subscribe button below and then clicking on the bell icon to receive notifications when new content becomes available. Until next time, thanks.